Hello friends, this is Priyanka. Today we are going to solve a problem on knife edge follower with uniform acceleration and uniform retardation motion. In this video, we are going to draw displacement diagram, velocity diagram and acceleration diagram. Now first, I will read what is the given problem. A cam with a minimum radius of 50 mm rotating clockwise at uniform speed is required to give a knife edge follower the motion as described below. To move outwards through 40 mm during 100-degree rotation of the cam. To dwell for the next 80 degree. To return to its starting position during next 90 degree and to dwell for the rest period of revolution, that is 90 degree. Draw the profile of cam. When the line of stroke of the follower passes through the center of camshaft and when the line of stroke of follower is offset by 15 mm. The displacement of follower is to take place with uniform acceleration and uniform retardation. Determine the maximum velocity and acceleration of the follower when the camshaft rotates at 900 rpm. Draw the displacement, velocity and acceleration diagrams for one complete revolution of the cam. So this was the given question. We will first move to draw the displacement diagram with some suitable scale. So we will take here scale 2 cm is equal to 10 degree. So in one complete revolution of cam, the angle covered is equal to 360 degree. So during this 360 degree, if we observe the question, the outstroke is given 100 degree, then dwell period is for 80 degree, then return stroke is for 90 degree and again dwell period is for 90 degree. And the motion of follower is with uniform acceleration and uniform retardation. So as per this scale, so 100 degree, that means we have to take 20 centimeter distance. So here we will select the 20 centimeter distance on this abscissa. Then the next period is dwell period. So during dwell period, the follower remains at rest. So here 80 degree, that means we have to take as per this scale 2 centimeter, that is 16 centimeter distance we have to take. Then for 90 degree we have to take 18 centimeter and again for remaining 90 degree we have to take the 18 centimeter distance. And on the ordinate we have to take the distance equal to stroke. So stroke is 40 mm. So again we will use the scale 1:2, that is 4 cm multiplied by 2, that is vertical distance 8 cm we will select. Now we have to make any number of even equal parts for outstroke and return stroke. So we will select the 6 number of equal parts and we will make here the 6 number of equal parts. So on calculator we can make 20 divided by 6 and that distance we will select here, and these are the 6 number of equal parts. So same here for the return stroke also, this scale is 18 cm. So 18 divided by 6, that is we have to take this scale, that is 3 cm each, and we have to mark here the points. Now we have to draw the vertical lines passing through these parts. We have to select the middle line because the motion is with uniform acceleration and uniform retardation. So for this outstroke and return stroke we have to select the middle line. So we have to select the line in such a way that on the left hand side and right hand side there are equal number of parts. So if we observe, here is 1, 2, 3, that is on left hand side, and here is 1, 2, 3 on right hand side. So this is the middle line. So same number of equal parts we have to make. So we have to take here the 6 number of equal parts. So these points are getting selected. So in the same way here also we have to select the middle line and we have to make the 6 number of equal parts. Now how to draw the motion with uniform acceleration and uniform retardation. So for that we have to draw, or we have to join the opposite corner. So we know that the follower is at initial position at this corner, and when outstroke is getting completed it will reach at this corner, and during the period of dwell it will remain at rest, that is here is also it will remain, and during return stroke again it will return to its initial position, that is at this corner. So So first task is we will join these corners. So these corners, if we join, the line is passing through the middle point. So here is the middle point that we have selected. Then during period of dwell it will remain constant, and again we will join here the opposite, and here also during period of dwell it will remain constant. Then the main important thing is that we have to give the notations. So these notations we have to give in such a way that to avoid confusion. So at initial state we will give here the letter A, then B, C, D, E, F, G. Then here also on this middle line we will give the letters, that is A dash, B dash, C dash, D dash. Then here is E dash, F dash, E, F, G, that is G dash. Then here I will again start the letters, that is H, I, J, K, L, M, N. So again here we have started the letters from the bottom, but in the return stroke we have to give the letters from here. So first letter is H, so I will give here as a H dash, then I dash, J dash, then here is K dash, then L dash, M dash, and last one is N dash. So in this way these letters that we have to give. Now we have to join these corners with these letters. So in which direction? So this, for the first corner on the outstroke we have to join this letter A to this line, then A to B, then A to B dash, A to C dash. So I will join here A to B dash, A to C dash. So in the same way now this opposite corner for the upward, this is the lower section and this is the upward section. So we have to join the left hand side corner in lower section of this main line, and then the opposite corner for this upper section. So here we have to join. Then in the same way we have to move for the next. So this is the upper section and this is the lower section. So for this upper section on return stroke we have to join this corner. So I will join here. Then in the same way for this lower section we have to join the opposite corner. Now we have to select the points, and these points will be the trace points. So how to select? So for that we have to select the point of intersection. Now here the point A is the point of intersection with this initial line, and this is the starting point. So I will write here as a capital A, this point. Then the next is, this is the second line passing through this corner and which is joining to B dash. So point of intersection with this B we have to select. So I will say that this point will be capital B. Then in the same way this is the line passing through this corner and joining C dash. So C dash to C, that is the point of intersection passing through line passing through from this point C. So this point will be C. Then same way A to D dash, and here this line passing through D. So here this point of intersection we will say D. Then in the same way here is the line passing through E. So we have to select the line, that is we have to select the line joining to point E dash. So here is the point of intersection and we will give here the letter capital E. Then in the same way for F, so here is the line passing through F. So we will select the line joining to F dash. So here is the point F, and the next is point G. So here we will select the line that will join to G dash. So here F and capital G. So in the same way, so these are the trace points. So again we will move for the next. So here is H. So H to H dash. So here is the next point, capital H. Then I. So this is the line passing through I. So we have to select the point of intersection with line joining to I dash. So here is the I. Then next is J. So J to J dash. So here is capital J. Then here K to K dash. So here is capital K. Then L to L dash. So here is the line joining to L dash, and here is the line. So I will say this trace point will be capital M. Then M to M dash. So here will be capital M. And then N to N dash. So here is n dash, that is the last point. So n to n dash, that is this point. So I will say M. So in this way, so these trace points are there. Now we have to join these trace points so that we will get the curve. So now I will join with the black marker so you can see it easily. So this is the curve, and here also now here it will remain rest. Then H to I to J, J to K, K to L. Then here is M, and here is N. So this is the curve. Now we will move to draw the profile of cam for the first condition. So what is the condition given? When the line of stroke of follower passes through the center of camshaft. So for that we have to first draw the circle with minimum radius 50 mm, and that circle is known as the base circle. So take O as a center and draw here one base circle. Now what is the center of camshaft? So center of camshaft is nothing but this center point O. So we have to draw one line passing through this point O in the form of dash, and the condition is given that the line of stroke of follower. So what is the line of stroke of knife edge follower? So here this tip is known as the stroke. So that is the line of stroke passing through this tip of this knife edge follower. So we have to draw one line passing through this point O, and that will be the middle line of this knife edge follower, and that will passing through this tip of this knife edge follower. So this is the initial position of the knife edge follower. Now here it is given that for one complete revolution the angle covered is 360 degrees. So for this circle also the total angle is 360 degrees. So from the initial position we have to join these lines, that is this point O to A. So I will join this line, and now from this line we have to take the angle equal to outstroke, that is equal to 100 degrees. So we will mark here one point, and again we will draw one line. So this total angle is 100 degrees. Then next angle is for the period of dwell, and that is equal to 80 degrees. So here this angle is 80 degrees. Next is for the period of return stroke, that is 90 degrees. So we have to take here the 90 degree angle, and remaining also the angle is 90 degrees. So in this way we have to select the angles. Now for the period of the outstroke and return stroke we have to again make equal number of parts as made in the displacement diagram. So here there are 6 number of parts. So for 100 degree also we have to make 6 number of equal parts, and for this 90 degree in the return stroke also we have to make the 6 number of equal parts. And then from these equal parts we will draw the line passing through those selected points. Now we will select the trace points as in the displacement diagram. So when these lines are drawn, then we will give here the letters. So if we observe the displacement diagram, for the initial position the letter is A. Then for the first part here is B. For second part it is C. So in the same sequence we have to give the letters. So if we observe A, B, C, D, E, F, G. Then at the starting point of return stroke the point is H. So H, I, J, K, L, M, N. Now we will locate the trace point. So at this point A, trace point is capital point A, and it is on this base circle. Then from this small b we will take the distance that is equal to capital B. So this distance, and if we observe the return stroke the distance is same here. So distance is not same because these angles are different. So we have to take here B to B. So I will take this point B to capital B. Then next is C to capital C. So here from C to capital C I will mark one point. So here is the capital C. Then D to capital D. So here from D to capital D. So we have to mark here the point, that is D to capital D. Then E to capital E. Then here we have to mark one point, that is E to capital E, and so on. So in the return stroke also we have to select the points. So if we observe, here is the N, so we will select here as a capital N, that is on the base circle. Then small m to this point of intersection, that is M. So if we measure this distance, we will plot here this capital M. Then here also L to capital L. So here is the point. So with the help of compass, we will take this distance and we will plot here L to capital L. Then again K to capital K. So this point is known trace point. I have shown with the capital letters. So we have to take that, and here is the capital K. And we have to repeat the procedure for the remaining points also. Now all these points are getting selected, and now we will join all the points with the help of smooth curve. So for A to capital B, then capital B to capital C, then here is D, then E, then here is F, then G, and now here is period of dual. So here this length of G, that is, and here is H, that will remain same. So we have to join this, and then here from H to I, then here is J, then K, L, M and N. And for remaining dual period it will remain constant. So if we observe this, that is with the help of black marker, I have shown the curve and it is the cam profile. Now we will move to draw the profile of cam for the second condition. So here it is given that when line of stroke of follower offset by 15 mm. So for that we have to first draw the base circle with 50 mm radius, and then we have to draw another circle with same center, that is called as offset circle with 15 mm. It is given that the line of stroke of follower. So for this knife edge follower, this tip is the line of stroke, and the line passing through this tip is known as the line of stroke, is offset by 15 mm. So if we draw one line passing through this end point of the circle, that is the vertical line in the form of dash, so we have to take this as a middle point, and this line will be passing through this tip of the knife edge. So here is the knife edge follower. So we can say that this is the initial position of the knife edge follower, and it is offset by 15 mm, because from the center O, this is the center O, the distance of the line of stroke is 15 mm from the center O, and this is the initial position. So if we observe the displacement diagram, the initial position is at this point A, and we can say trace point is capital A. So here is the trace point, that is capital A, and on this base circle we will give here the small letter A. Now if we observe, out of this 360 degree, this total angle covered by this circle is also equal to 360 degree. We have to make the outstroke is 400 degree. So we will join this line O to A, and if we take this base line, then we have to take here as a angle is equal to 100 degree, that is for outstroke. So here is the line. So next is 80 degree line. So here again we have to mark one point for 80 degree. So this is the dwell period, and then again there is the 90 degree for the return stroke. So here is the angle 90 degree, and remaining angle is also 90 degree, that is the dwell period. So for the outstroke and return stroke, we have to make the equal number of parts as made in the displacement diagram, that is 6 number of equal parts. So here I have selected the points which are the number of equal parts for the outstroke also and return stroke also. Now we have to locate the points on the base circle. So here is the base circle. So I will join the selected point and this center O, and then we have to select the line passing through this base circle. So here is the next point. Then in the same way for the second point also I will mark here the second point. Then for third point also I will mark here third point. Then here is fourth, and then here is fifth point. Then in the same way for the return stroke also I will mark the points that is I have to extend the line joining this O and selected points. Now we will give the letters as in the displacement diagram. So here the first is A, that is the initial position of the followed. So next is B, C, then here is D, E, F. Then here last one is G. Then if we observe starting of return stroke is H. So I will say here H, I, J, K, L, M and last one is N. So in this way these points are getting selected. So when there is the condition that is the line of stroke is offset, then for this offset circle we have to draw the tangent passing through the selected points. So I will draw here the tangent passing through this point B. Then same way passing through this point C, I will draw one tangent. Then here from this D, then E. So the tangent should be to the offset circle. Then for H also we have to draw one tangent. So these are the tangents. Now with the help of compass we will select the distance. So first we will take the distance. So initial trace point is capital A. So I will show these trace points with the help of the black marker. So here the point is capital A. So next trace point, that is from small b to capital B distance. So with the help of compass we have to transfer this distance. So here is the capital B. Then next is C to capital C. So again from this C to capital C. Then again D to capital D. So here from this D to capital D. Then we have to select in the same way all the distance. So from the return stroke how to select? So if we take from N. So N itself there is the point of intersection on base circle is capital N. Then from M to capital M. So again if we observe here is the line passing through M. So here I will select this line point as a capital M. Then L to capital L. So here L to capital L. Then again K to capital K. So this is the middle point. So we have to select here K to capital K. And we have to repeat the procedure. If we join all the trace point with this smooth curve with the help of black marker, then this curve is known as the cam profile. Now we will move for the calculation part. Here we have to calculate the maximum velocity and maximum acceleration. So for that we will first observe what is the given data. Now here the stroke is given 40 mm. So we have to convert it into meters, that is 0.04 meter. Then the displacement at outstroke, that is theta O, which is equal to 100 degree. So this degree we have to convert it into radian. So how to convert? So if we have to multiply this degree with pi by 180. So if we observe this calculator here at the bottom there is pi. So if we press here shift and this bottom button here, this is the pi value. So pi multiplied by 100 divided by 180. So it is 1.745 rad. That means in this way we can convert here this degree value in terms of rad, and in calculation we have to refer this value. Now next is theta r, that is the displacement, or we can say angular displacement during return stroke. So it is in terms of degree, that is 90 degree. So again we will multiply here with pi by 180. So which is equal to 1.571 rad. Then the number of revolution 900 rpm. So from that we can calculate the omega. So omega, that is the angular velocity 2 pi n by 60. So n we have to take 900, and which is equal to 94.26 rad per second. So this omega is getting calculated. Now we will move for the calculation of maximum velocity during outstroke and return stroke. So what is the formula? So velocity, because the motion is uniform acceleration. So maximum velocity 2 omega s by theta o. So theta o we have to take here in rad. So 2 into omega. So omega is calculated into s. We have to take this stroke in meter divided by theta o, 1.745, which is equal to 4.32 meter per second. In the same way, we will calculate maximum velocity during return stroke. So what is the formula? That is 2 omega s divided by theta r. So theta r we have to take 1.571. So with this same notations we will take here if we calculate this 4.8 meter per second. Now we will move for the maximum acceleration. So during outstroke we have to use the formula, that is AO. So for outstroke we will use here suffix O. 4 omega square s by theta o square. So here omega, that is calculated s, we have to take in meter, and theta o, that is we have to take here 1.745 square. So when we put the value, we will get 467 meter per second square. Now what is the maximum acceleration during return stroke? So for return stroke we will use here suffix r. So again the same formula is there, that is 4 omega square s divided by, for return stroke we will use theta r, that is theta r square. So 576 meter per second square. Now if we use this maximum velocity during outstroke and return stroke, we will draw the velocity diagram, and if we take the maximum acceleration during outstroke and return stroke, we can draw the acceleration diagram. While drawing the velocity diagram and acceleration diagram, we have to take the same distance as in the displacement diagram. So below that we have to select this first line, or we have to extend this initial line, then we have to extend the middle line of the outstroke, and then we have to extend the end line of the outstroke. Then in the same way, this is the period of dwell. Then next is starting line of the return stroke, that we have to extend, then middle line of the return stroke, and then the end line of the return stroke that we have to extend. And the next period is the next line is for the period of dwell. Then how to draw the velocity diagram? So for outstroke it is given 4.32 meter per second. So what is the structure of this velocity during outstroke? So the maximum velocity is achieved at this middle point. So we have to show. So initially the velocity is at 0. So starting is from this 0, and the maximum velocity is achieved at this middle point. So we have to take with uniform increase in the velocity during the first half of this outstroke, and during the second half of the outstroke this maximum velocity is decreased to the initial point. That is, I have to show this uniform decrease in velocity. Now it remains constant during this period of dwell. And next for the return stroke, that is again there is uniform decrease of 4.8 meter per second. So this maximum velocity is again achieved at the middle point. So for the return stroke this is the middle point. So again we have to show this, that is maximum decrease in velocity. So in this way we have to show, and during return stroke we have to show below this line, and again it is getting increase up to this line 0. So again we have to show this with uniform line or the straight line to the initial, and during the dwell period here it remains constant. So I have to show that this is the V max, that is VO, and here that is we can also write here 4.32 meter per second for this vertical line, and here we can also write here 4.8, or we can say VR. That is the maximum velocity during return stroke, which is equal to 4.8 meter per second. So this is the velocity, that is maximum velocity during outstroke and maximum velocity during return stroke is achieved during first half of the stroke. That is, this is the total angular displacement. So first half it is getting achieved. Now related to this we will move for the acceleration diagram. So maximum acceleration during the outstroke, that is 4 467 meter per second square. So if we observe again, it is getting achieved during this first half. So during this first half, because this uniform acceleration is there, so we can say that here during first half it is getting achieved. So I will draw this straight line during the first half, and again it will become to 0, and then we have to show this line that is below this horizontal line, and then here we have to show this graph. That means here this is the maximum acceleration, that is 467 meter per second square, or we can say this scale that is equal to AO, that is getting achieved. And during the second half there is decrease in acceleration, but there is the decrease in acceleration with uniform, because for this uniform acceleration and retardation we have to show this straight line. Then during the period of dwell it will remain at the mean position, and then again for the return stroke. So return stroke during the first half we have to draw this below the line. This is return stroke, that is 567. So we can say the scale, that is this vertical line, will be equal to AR, and then during the second half we have to show again there is increase in the acceleration. So we can show that this vertical line, that is from this mean line, that is scale is equal to AR. That is the maximum acceleration during return stroke, and this is the maximum acceleration during outstroke. So this is the velocity and acceleration diagram.